Hey,
It's the units of measure libraries that I have found are sufficient reason to love Python. No, let me put it this way: to stop hating Python so much.
All right. And what was the third one?
The new type annotation stuff is very it's promising. Today I use it just as documentation. I occasionally run MyPy over it, but I see in the future it's being integrated with test generation, which now I'm starting to get all googly moogly, because if I can write types that specify domains and then generate tests that fuzz on those domains, I'm getting really, really excited. So.
awesome.
Good.
So Eric, where are we right now?
Well, we are at the PLAN conference in Seattle. This is our second PLAN. Last one was in Menlo Park. This time we're in Seattle.
Awesome.
And it's great to have like a whole bunch of language geeks together for 2 days and get do interviews and listen to talks about like languages, compilers, runtimes, all the fun stuff.
Love it, man. And the level of like depth is incredible.
Yep, that's the whole goal, right? You bring together the geeks and they go deep.
Right on, man. And there's this face we haven't seen for way too long as well. How are you, man?
Charles, great to see you again.
Great to see you.
Yeah.
So you're at Amazon now.
I'm at Amazon.
Building robots?
Well, I started off in retail, doing dashboards for some retail back-end systems, real-time stuff, and then created Primaire with 2 other guys.
Crazy.
The drone delivery program, and
Wow.
then segued from that into just robotics in general. So Primaire is an instance of robotics. It's automated drone delivery, and now there are going to be robots everywhere. There isn't any aspect of delivery. Well, look at it this way: worldwide, next day, 0-touch delivery. No human touches a package. Tell me something that doesn't need to be automated.
Emotion?
Yeah.
Okay. That's amazing. So you're using all your physics skills and your programming.
Yes.
Are you monads? Are you using monads and monoids?
Well, yes, except I don't talk about them because it still scares people needlessly. The best use of monads that I've been making lately is in test generation. So there are test generation libraries for Clojure and for Python that are monadic. You build strategies for generating test cases by monadic composition of other strategies. And it's quite beautiful, but you don't have to tell anybody that's what you're doing. They just see composition, and then they're happy because their code is easy to read and easy to understand and easy to deal with and fast.
So instead of don't fear the monad, now we're in a world of don't see the monad.
Exactly.
Don't think about it.
But that's exactly what monads should be, right? I think they don't require attention; they should just do the work.
It should be invisible.
Yep.
Like stack frames. We were just listening to how to make Python runtime faster by using stack frames. Does anybody think about stack frames? They're invisible, but that's the way to make your code churn along. So monad's the same way. Just a nice way of composing things that have context.
Excellent. For people who don't know, you're now a director of engineering at Facebook.
Yep.
Tell us about what you've been doing.
Yep. So I've been doing some language stuff, but these days I'm all into machine learning. So I jumped onto the machine learning hype. And don't laugh. I think it's similar to what Brian said. If you look at the future of programming, more and more of our code will be learned, which means that developers need to combine machine learned model with traditional code. And our programming languages, our current programming languages, are not well set up to do that. And so we're building new languages. It's called probabilistic programming, where probability distributions or probability monads are built into the language, but they become invisible because they are built in. So you make them invisible, just like a good monad should be, right? They should be hardwired in.
Okay.
And then besides that, we're also making it easier for developers to use machine learning to optimize services and products. And then the second thing is we're using machine learning to make developers more productive.
Awesome.
And so it's applications of machine learning in the developer space. And great fun.
Awesome. So is it the end of Boolean logic? So when you say probabilistic programming, it's no longer 0, 1.
Exactly, that is exactly the problem that you're facing, right? Like, you know, right now a conditional returns true or like a Boolean expression returns true or false, and then you can make, you know, a decision in your if then else statement. But if you're in a probabilistic world, it might be true with like 80% certainty and false with 20% certainty, and now you have to kind of propagate that uncertainty in your kind of like, you know, operational model of your program.
Cool. So the uncertainty monad.
Well, we have exactly the same issue in robotics. If you tell a robot to do something, it's not going to do exactly what you tell it. Instead, it's going to do something with a little bit of uncertainty. And so you need to estimate these uncertainties and you need to propagate them through. So you're not just doing computations with numbers anymore, you're doing computations with probability distributions. So it's Bayesian programming everywhere. It's Thomas Bayes and Rudolf Kalman, and these guys are...
Right on, man.
Absolutely.
Okay, well, we're going to see you soon.
All right, yeah.
And get out there and MC, man.
Okay.
Take care, you guys.
Okay, bye-bye.
Great to see you all again.